Hello. Okay. So we'll start our class. It's 10 o'clock now. We'll start our class. तो लैंथनाइड केमिस्ट्री में जो लास्ट क्लास है आपके सिलेबस में, दैट इज सेपरेशन ऑफ लैंथनाइड्स. सेपरेशन ऑफ लैंथनाइड्स में देयर आर वेरियस मेथड्स. वो जो आपके सिलेबस में है, दैट इज आयन एक्सचेंज मेथड, एज यू कैन सी इन द स्क्रीन. तो बेसिकली इट इज़, पहली बात तो ये है कि separation of lanthanides is difficult. Number one point, separation of lanthanides is a difficult process. It's a difficult process. क्यों? Because हमने देखा है, because of the lanthanide contraction. lanthanide contraction की जो 3 पार्ट्स हैं उसमें हमने इस टॉपिक को डिस्कस भी किया था, सेपरेशन ऑफ लैंथनाइड्स को, लेकिन उसमें वहाँ पे मैंने इसको कॉन्सिक्वेंसेस में डिस्कस किया था वेरी शॉर्टली इन कपल ऑफ मिनट्स. बट हियर इट इज़ अ कंप्लीट टॉपिक, क्योंकि ये टॉपिक एग्जाम्स में पूछा जाता है. इवन इन मोस्ट ऑफ द कॉम्पिटिटिव एग्जाम्स आल्सो दिस क्वेश्चन इज आस्क्ड. सो सेपरेशन ऑफ लैंथनाइड्स इज अ डिफिकल्ट जॉब. व्हाई? बिकॉज देयर साइज इज वेरी सिमिलर. बिकॉज साइज ऑफ lanthanide ions is very very similar. If size similar ho, then the most of the times it is very very difficult to separate the lanthanides from a given mixture. Okay, so it is difficult to separate lanthanides from a given mixture means अगर हमारे पास एक मिक्सचर हो lanthanides का which contains for example cerium tripositive, इसी तरीके से we have a neodymium tripositive, promethium tripositive. So we have a mixture of lanthanides for example. अब इस मिक्सचर से we have to separate each lanthanide. It's a difficult task. Why? Because the size of these ions is very similar. इनको separate करने के लिए there is a method called as ion exchange method. This one. So method for separation of lanthanides is ion exchange method. ठीक है. So with the help of this method we can separate various lanthanide ions from a given mixture in the solution. तो ये मिक्सचर आपका solution में होता है. ठीक. Okay. Now, so we'll go straight forward to the ion exchange method. What's this ion exchange method? As the word suggests, there is some sort of ion exchange. Means, what do you mean by ion exchange? Basically, इस method में क्या होता है? We use, as it is a separation method, so it behaves like it's like a column chromatography method. जब हम कहेंगे it's like a column chromatography method, then immediately we have to keep in mind that we'll be using some sort of column. So यहाँ पे आप देख लीजिए, this is a column, a typical column, a long tube. ठीक है. तो इस column में क्या होता है? सब material is packed. एक packing material होता है, polymeric material इसमें. So that's packed throughout the column. ठीक. अच्छा, उस material में we have some active sites. Show them by these dots. इस मटेरियल, इस कॉलम को हम पहले पैक कर लेते हैं विद सम पॉलीमेरिक मटेरियल. अब वो पॉलीमेरिक मटेरियल क्या होता है उसके बारे में हम डिस्कस नहीं करेंगे. हमारे लिए जो इम्पोर्टेंट वो ये है दैट इन दैट पॉलीमेरिक मटेरियल देयर आर सर्टेन साइट्स कॉल्ड एज एक्टिव साइट्स और आयन एक्सचेंज साइट्स. ठीक है. नाउ विल डायरेक्टली टॉक अबाउट दोज आयन एक्सचेंज साइट्स. तो साइट्स बेसिकली क्या होती हैं? If I show, like, let us say this is your polymer chain, so these are the sites. वो sites basically क्या होती हैं? These sites, these active sites, they basically contain certain specific functional groups. either SO3H sulfonic group or carboxylic acid group. यूजुअली ये दो ग्रुप्स दीज आर मोस्ट कॉमन. यही ग्रुप्स अटैच होते हैं इन स्पेसिफिक साइट्स पे. ठीक है. अच्छा, ये जो अब पूरा मटेरियल इसमें हमने पैक किया है विच कंटेन सर्टन स्पेसिफिक साइट्स where we have presence of these groups. So this whole material is basically called as cation exchange. So this material, this packing material which contains these specific groups, it's called as cation exchanger. Q. Look here. Let us say why it's called ion exchange method or why it's called a cation exchanger. अब हम सीधे लेते हैं. Let us say this is a polymer chain. This is one group here attached to this polymeric chain, and this group is SO3H. इस SO3 में H will be in the form of plus because it's an acidic proton. So when it comes in contact with a cation, let us say lanthanide in general, this lanthanide ion, it exchanges this proton. क्या मतलब? lanthanide ion इस जगह पे आ जाता है. तो रिजल्ट क्या होता है इससे? Result is that now we have this type of situation. This is polymer SO3 नेगेटिव और इस पर lanthanide अटैच होता है या lanthanide इसके साथ बॉन्ड बना लेता है, lanthanide ion. Now in this case what has happened, this H positive has been replaced by this lanthanide ion. You can see here, that is why it's called as an ion exchange. Since यहाँ पे cation exchange हुआ है, it's called cation exchanger. So ion exchange means there is ion exchange during the process of separation. ठीक है. This is the main principle, that we are using a polymer, a cation exchanger which has certain specific sites, for example sulfonic acid group or carboxylic acid group. इसी तरह की carboxylic acid group में भी you have H plus. Replace that H plus by the lanthanide ion. That's why it's called as the ion exchange method. ठीक है. Okay. उसके बाद हम क्या कर लेते हैं? So now we have packed this column with the ion exchange material, which is a polymeric material 100%. So these are the active sites available. Just mention. Okay. So once we packed this material with the once we have packed this column with the ion exchange material, so we have these active sites. उसके बाद in this step number 1 what we do is now we are adding our solution. For example, we have this mixture of lanthanide ions which we are going to separate. This. So let's say these are lanthanide ions. So I'm keeping them of different sizes because we know they have different sizes because of the lanthanide contraction phenomena. So what we do is that we'll add this over the column, or we'll pour this in the column, or we say we'll add this to this packing material. तो हमने जैसे इसको ऐड कर लिया यहाँ पे, so these lanthanide ions, they will replace H positive from these sites. So from all these sites H positive will get replaced. ठीक है. So we'll show this a replacement of H positive ion by the lanthanide ion by a relation here. For example, let's show it here. So we'll show it by a relation. So in the step number 1 we have our this is your polymeric material which has the functional group SO3H. So in the step number 1 it reacts with the lanthanide ion. General formula Ln plus. So what it forms, it undergoes exchange phenomena, and then we have SO3 Ln. Then N plus. This is negative. So this is our step number 1. So we have replaced this site by lanthanide cation. This is step number 1. So this is your ion exchange method. That means in the column now, all the sites are occupied by, so if you see in the column now, all the sites, H positive sites, they are occupied by this lanthanide ion. इसको इसको हम दूसरे तरीके से भी दिखा सकते हैं. लेट अस से फॉर एग्जांपल if we consider our lanthanide as, let us say, let us show it like this. This is your polymeric material. So polymeric material is usually the resin. That resin has H. हम इसको इस मेथड से भी दिखा सकते हैं. Now that H gets replaced by your lanthanide ion LnL positive, and then you have the exchange with the help of this equilibrium. You can show it resin, RESIN, and then LN. ठीक. Now जो हम मोस्ट कॉमनली lanthanide स्टडी कर लेते हैं यूजुअली, दैट इज द lanthanide ट्राई पॉजिटिव, बिकॉज ट्राई पॉजिटिव इज द मोस्ट कॉमन ऑक्सीडेशन स्टेट. So then we can also show it by resin stands for RH plus lanthanide plus 3. अब lanthanide plus 3 में 3 plus charge है. H positive gives 1 unit charge. That means for replacing lanthanide plus 3 we need 3 units of lanthanide sites. So we'll show it like this: 3 times R H, then it gives you R 3 and lanthanide. So this way we can show it the replacement of H positive by lanthanide ion. क्लियर का संख्या आवाज करो मैनेज पता शो ठीक. अच्छा, so this is your equilibrium in the step number 1, that all the sites where H positive was available, they are replaced by the lanthanide to form R3Ln. Step number, in the step number 2, we have, so let us go to the column, then write down the step number 2. So at each and every step, so this is our column. So what we have done is we have replaced for eluting the ions. Now what type of solution? That's a buffer solution. Okay. And that buffer solution contains ammonium. That buffer solution contains, we have citric acid. So this is the solution we'll use for eluting the ions from the column. Okay. So in this step number 2, what will happen? These ions will get eluted. You can show them by this process. So you have your lanthanide ions attached to the column R3, and result is this lanthanide will get replaced. So we have ions are set free. So जो lanthanide ions यहाँ से free हो जाते हैं, so what they will come out of the column. तो जैसे ही this ammonium ions will now occupy these sites. So after pouring this buffer solution here, these sites which were occupied by the lanthanide ions, so now they will be occupied by the ammonia. So the lanthanide ions will come down. And अब क्वेश्चन है दैट हाउ इज इट सेपरेशन. सेपरेशन किस बेस पे होती है? उसके लिए जो बेसिस है दैट इज द दिस इज द मेन पॉइंट हियर, हाउ द lanthanide are getting separated. तो बेसिकली जो आपका सोल्यूशन था lanthanide ion 3 plus. ये solution में since we have water also in the surroundings, water molecules. So water molecules will do the hydration of these ions. Hydration means that your lanthanide ion or lanthanide cation, they will be separated by, they will be surrounded by the water molecules OHH. Since it has a plus charge, the negative end we have oxygen here. We know water is okay. So this way it forms a hydration shell here. So we have a hydration sphere here. So the result is that now each ion is basically hydrated in the solution. तो जो हमारा sample था जिसमें we had various ions present, these ions are basically hydrated ions. यही इसमें main important point है, hydrated ions. How much a particular ion will undergo the hydration, it depends on the charge density. Charge density. Charge density, you have quantity of charge divided by the size. अब ये सारे ions they are tripositive. That means आपका charge ये जो है that's fixed. Now size, if we move from left to right, in the lanthanide series we have ions starting from cerium, then we have promethium, samarium, europium, gadolinium, terbium, dysprosium, holonium, and then finally we have lutetium. तो ये जो 14 elements है in the lanthanide series, from left to right size decreases. Now as the size decreases, that means आपका जो denominator है it is decreasing from left to right. So that means overall the charge density decreases from left to right. इसका मतलब जो lutetium है इसका size बहुत, उसका आयन का साइज बहुत कम होगा बिकॉज चार्ज डेंसिटी बहुत ज़्यादा है. इट मीन्स इट विल अंडरगो द लार्ज हाइड्रेशन. जब हाइड्रेशन की ज़्यादा होगी दैट मीन्स इन दिस सॉल्यूशन एंड द लीस्ट हाइड्रेटेड साइज विल बी फॉर द सीरियम. ओके, सो कीपिंग दिस इन माइंड, जैसे ही हमने कॉलम में ये सॉल्यूशन को ड्रॉप किया था तो रूल ये है कि जिस लैंथनम का, जिस आयन का हाइड्रेटेड साइज ज़्यादा है, that will get least absorbed at these sites. या उस आयन के लिए एक पर्टिकुलर साइड पे बैठ जाना या स्टिक करना, its chances are less or it is weak because size is very very large. While as वो आयन जिसका साइज स्मॉलर है that will get attached to those sites in the step number 1. ठीक है. So any ion which gets attached with a stronger affinity, that means it is difficult to take out that particular ion from the column. जो ion इस column में affinity के साथ, strength के साथ बैठ जाएगा, it is whose size is larger, they will be having less affinity to these sites. When they have less affinity to these sites, that means they are loosely bound. When they are loosely bound, that means once you pour the solution, buffer solution, so those ions which are loosely bound, they will come first. So this is दो कॉलम निकल जाएंगी. ठीक है. So that means जो कॉलम से पहले निकल जाएगी size of hydration, that means, so that means lutetium plus the other end, since its hydrated size is larger compared to this, it will be attached to the column loosely. It means it will come first. So it will come first out of the column during elution. Technically, it will be eluted first from the column. And the cerium, who is the hydrogen, it will be eluted last. ये last पे आ जाएगा. इसी तरीके से separate the lanthanide ions with the help of ion exchange method. Simple phenomena we are using basically the concept of hydration size. Those ions whose charge density is more, they will be hydrated to a larger extent. इसका मतलब ये है that their size will be larger, so that means they will be firmly attached to the column. उनको remove करना it is very, जिनका size larger था they will be loosely attached to the column, that means they will be easily removed or they will be removed in the first extent. So this was the basic phenomena about the separation of lanthanides. So I will be attaching also a PDF file to this probably tomorrow, as it is not possible today. So if still you have any question, you can pose the question, or you can also pose the question in the WhatsApp group. So yeah, otherwise you can close this. These business in country, I don't know what was the reason why the internet connection was off and on. Okay, so this is all about the separation of lanthanides with the help of a column. It's simply an ion exchange method where we have certain specific active sites on the material which is packed in the column, and those active sites contain H positive ions which could be replaced by the lanthanide hydrated lanthanides. Hydrated lanthanides which are hydrated to a larger extent, they will be loosely bound. That means while eluting with the help of solution, they'll be eluted first, while those ions which have smaller size, or they have smaller hydration, so they will be attached firmly. That means they will come at the end. So this process we can gradually separate lanthanides with